efforts were being felt in the design. Numerous 68K machines were already on the market, notably the Apple Macintosh, and the 32016 never saw widespread use. The 32016 has a 16-bit external data bus, a 24-bit external address bus, and a full 32-bit instruction set. It also includes a coprocessor interface, allowing coprocessors such as FPUs and MMUs to be attached as peers to the main processor. The MMU is based on demand paging virtual memory, which is the most unusual feature compared to the segmented memory approach used by the competition, and has become the standard for how microprocessors are designed today. The architecture supports an instruction restart mechanism on a page fault, which is much cleaner than the Motorola approach to dump the internal status in a page fault, which has to be read back before the instruction is continued. NS32016 microprocessor NS32081 FPU. While often compared to the 68KS instruction set, this was rejected by NSC employees. One of the key marketing phrases of the time was "elegance is everything," comparing the highly orthogonal Series 32000 to the Clutch. One key difference is Motorola's use of address registers and data registers, with instructions only working on either address or data registers. The Series 32000 has general-purpose registers, described as address data registers in technical documentation. 9.32032. The 32032 was introduced in 1984. It is almost completely compatible with the 32016, but features a 32-bit data bus, although keeping the 24-bit address bus, for somewhat faster performance described as mini-computer performance comparable with that of a VAX11 system. 1039. There was also a 32008, a 32016 with a data bus cut down to 8 bits wide for low-cost applications. It is philosophically similar to the MC68008, and equally unpopular. National also produced a series of related support chips like the NS32081 Floating Point Unit, FPU, NS32082 Memory Management Units, MMUs, NS32203 Direct Memory Access, DMA, and NS32202 Interrupt Controllers. With the full set plus memory chips and peripherals, it was feasible to build a 32-bit computer system capable of supporting modern multitasking operating systems, something that had previously been possible only on expensive mini-computers and mainframes. Die photos. NS32032 microprocessor NS16032 CPU NS16081 FPU NS32032 CPU NS32081 FPU NS32082 MMU NS32202 Interrupt Controller NS32203 DM Controller 32332, 32532. In 1985, National Semi introduced the NS32332, a much improved version of the 32032. From the datasheet, the enhancements include the addition of new dedicated addressing hardware, consisting of a high-speed ALU, a barrel shifter and an address register, a very efficient increased 20 bytes instruction prefetch queue, a new system /memory bus interface /protocol, increased efficiency slave processor protocol, and finally enhancements of microcode. There was also a new NS32382 MMU, NS32381 FPU and the very rare NS32310 interface to a WITC FPA. The aggregate performance boost of the NS32332 front-piece enhancements only made it 50% faster than the original NS32032, and therefore less than half the main competitor. The MC68020. National Semi introduced the NS32532 in early 1987. Running at 20, 25 and 30 MHz. It was a completer design of the internal implementation with a 5-stage pipeline, an integrated cache forward/MMU and improved memory performance, making it about twice as performant as the competing MC68030 and I80386. At this stage RISC architectures were starting to make inroads, and the main competitors became the now equalized M29000 and MC88000, which was considered faster than the NS32532. For floating point, the NS32532 used the existing NS32381 or the NS32580 interface to a WITC FPA.11. The NS32532 was basis of the PC532, a public domain hardware project, and one of the few to produce a useful machine running a real operating system, in this case, Linux or NetBSD. The semi-mythical NS32732, sometimes called NS32764, envisioned as the high-performance successor to the NS32532, never came to the market. Swordfish, a derivative of the NS32732 called Swordfish, was aimed at embedded systems and arrived in about 1990. Swordfish has an integrated floating point unit, timers, DMA controllers and other peripherals not normally available in microprocessors. It has a 64-bit data bus and is internally overclocked from 25 to 50 MHz. The key architect of the Swordfish is Donald Alpert, who went on to manage the architectural team designing Pentium. The Pentium internal microarchitecture is similar to the preceding Swordfish. The focus of Swordfish was high-end PostScript laser printers, and performance was exceptional at the time. Competing solutions could render about 1 new page per minute, but the Swordfish demo unit would print out 16 pages per minute, limited only by the laser engine mechanics. On each page it would print out how much time it was idling, waiting for the engine to complete. The Swordfish die is huge, and it was eventually decided to drop the project altogether, and the product never went into production. The lessons from the Swordfish were used for the compact RISC designs. In the beginning, there were both a compact RISC32 and a compact RISC16, designed using Z. National never brought a chip to the market with the compact RISC32 core. National's research department worked with the University of Michigan to develop the first synthesizable Verilog model, and Verilog was used from the CR16C and onwards. Others versions of the older NS32000 line for low-cost products such as the NS32CG16, NS32CG160, NS32FV16, NS32FX161, NS32FX164 and the NS32M160/1/3, all based on the NS302CG16 were introduced from 1987 and onwards. These processors had some success in the laser printer and fax market despite intense competition from AMD and Intel RISC chips. Especially the NS32CG16 should be noted. The key difference between this and the NS32C016 is the integration of the expensive TCU, timing control unit, which generates the needed two-phase clock from a crystal, and the removal of the floating point coprocessor support, which freed up microcode space for the useful bit BLT instruction set, which significantly improves the performance in laser printer operations. making this 60,000 transistor chip faster than the 200,000 transistor MC68020. The NS32CG160 is the CG16 with timers and DMA peripherals, while the NS32FV/FX16X chips have extra DSP functionality on top of the CG16-bit BLT core for the fax/answering machine market. They are complemented by the NS32532-based NS32GX32 later. Unlike previous chips, there was no extra hardware. The NS32GX32 is the NS32532 without the MMU, sold at an attractive price for embedded system. In the beginning, this was just a remarked chip. It is unclear if chip was redesigned for lower cost production. Data sheets exist for an NS32132, apparently designed for multiprocessor systems. This is the NS32032 extended with an arbiter. The bus usage of the NS32032 is about 50%, owing to its very compact instruction set, or its very slow pipeline as competitors would phrase it. Indeed, one suggested application of the NS32032 was as part of a fault-tolerant transaction system employing two 32032s in parallel and comparing results on alternate memory cycles to detect soft errors. 5. The NS32132 chip allows a pair of CPUs to be connected to the same memory system, without much change of the PCB. Prototype systems were built by Diab Data AB in Sweden, but did not perform as well as the single CPU MC68020 system designed by the same company. Die photos. NS32C016 CPU, NS32381 FPU, NS32382 MMU, NS32532 CPU. Machines using the NS32000 series. Acorn Cambridge Workstation NS32016, with 6502 host. BBC Micro NS32016 second processor, 1, 2, 3. Canon LBP8 Mark III laser printer NS32CG16. CompuPro 32016 NS32016S100 card, 12. Encore Multimarks NS32032, NS32332 and NS32532 multiprocessor. EMU Systems MX NS32008. EMU Systems Emulator 3 NS32016. F Zurich Series Workstation NS32032. F Zurich Series 2 Workstation NS32532. F Zurich Series 3 Workstation NS32GX32. General Robotics Corporation Python NS32032 and N32016 Q-Bus card. Huracan VME532 NS32532 VME card, with cache. IBM RTPC. Some early models used the NS32081 FPU as a coprocessor for the IBM microprocessor. Intermec, previously ATEC and then UBI, Naval Printer NS32CG16. Laptop Unix System NS32032 and NS32332 CPUs. Lauterbach in Circuit Emulator ICE, System Controller 32-bit, first version in 1996, max 16 MB zip 20 RAM, Z180 to serve Ethernet. National Semiconductor ICM 3216 NS32016. National Semiconductor ICM 332-1 NS32332W/NS32016I/O processor. National Semiconductor System 32/20 NS32016 PC add-on board W/Unix. Opus NS16032 PC add-on board. PC532 NS32532. Sequent balance NS32016, NS32032 and NS32332 multiprocessor. Siemens PC-MX2 NS32016. Siemens MX300-05/10/15/30 NS32332 05/10 or NS32532 15/30 under Synix, MX300-55 and later use I486. Siemens MX500-75/85 NS32532 2-8X CPUs, sequent boards /MX500-90 uses 2-1211 486. Symmetric Computer Systems S/375 4 NS32016 used to cross-develop 386 BSD. Site Information Technology Unix Graphics Workstation. Tektronix 6130 and 6250 Workstation NS32016 and NS32032. Tolerant Systems Eternity Series NS32032W/NS32016I/O processor. Trinity College Workstation NS32332. Techlogix 9020 Network Controller NS32332. Techlogix 9200 Network Controller NS32CG160. Whitechapel MG1 NS32016. Whitechapel MG200 NS32332. Legacy. In June 2015, Udo Moller released a complete Verilog implementation of an NS32000 processor on OpenCores.13, fully software compatible with an NS32532 CPU with N32381 FPU. It is significantly faster when implemented on an FPGA 14. Both operating at a higher clock rate and using fewer cycles per instruction. References 1 Series 32000 Software Catalog. National Semiconductor Corporation. 1984. Retrieved the 8th of November 2021.
Yes, we not read this. The video splits in 2 minutes. But that was the NS32000. I will go upload this. I will make a note. I need it for the folders when I upload. NS32000. Start to get a little bit tired. It's 5:30. In about 1 hour we have the news in the Danish early evening news. I like to watch that because every night I made a video about Ukraine in Danish. It's day 82 today or 83 after Russia attacked Ukraine. But we need 2 more. The National Semiconductor page. We have it down there. That's 6 pages. That's another chip there. Yes, but the video splits. So let's stop. And I have 2 videos. I need to put public. But I will try to finish this 2 in the next hour. I hope, or just continue tomorrow.